Hello, myself Janil Popat. I welcome you all. Let us discuss consolidation today. This graph is showing general behavior of soil is showing that as the effective stress is increasing, void ratio of that soil is decreasing. Now, Terzaghi has defined some more empirical formulas like coefficient of compressibility. Now, as compressibility coefficient is defined as change in void ratio per change in effective stress, where it is denoted as AV. Coefficient of compressibility is denoted by AV and is equal to written as minus delta E upon delta sigma dash. Here it is written as negative. Why negative? We should be having question like this, but it is shown as negative sign due to the graph. Whenever effective stress will increase, the graph will go down, void ratio will decrease. That is why minus signature, minus sign is shown. Here delta E can be written as E0 minus E. E0 is initial void ratio and E is final void ratio by delta sigma dash. Now sigma dash minus sigma 0 dash. Now sigma dash, that is final effective pressure, sigma 0 dash, that is initial effective pressure. Another coefficient of volume change is defined. Coefficient of volume change is defined as change in volume per initial volume. It also can be written as delta V upon V0. Empirical formula for that is MV. It is denoted by MV, and formula for MV is minus delta E upon 1 plus E0 into 1 by delta sigma dash. It can be also written as delta V by V0 is equal to delta E upon 1 plus E0. Now, if the soil is confined, from all sides, so after compression there is only one dimension in which it can compress. So we can also write delta V by V0 as delta H by H0, that is thickness of the soil or height of the soil, is equal to delta E, or we can write E0 minus E upon 1 plus E0. Now we already know coefficient of compressibility, that is AV is equal to minus delta E upon delta sigma dash. So substituting this as AV here, MV can be AV upon 1 plus E0. Also MV can be written as minus delta H upon H0 into 1 upon delta sigma dash. It is nothing but in place of minus delta E upon 1 plus E0, we have put minus delta H upon H0. Furthermore, degree of consolidation is also defined. Here E0, that is void ratio initial, where ET is showing void ratio at time t, and EF, that is void ratio final. So these are the formulas which will be useful for numericals also. Let us move forward to pre-consolidation pressure. Pre-consolidation pressure is nothing but a temporary overburden to a soil which has been subjected to an external load and under which it is consolidated. Now, pre-consolidation pressure is very important to obtain. For obtaining or determining pre-consolidation pressure, Casagrande has given an empirical theory. Through this graph, we can determine pre-consolidation pressure. This graph is between void ratio and effective pressure sigma dash. This graph is obtained from a consolidometer test for consolidation of an undisturbed clay sample, and it is plotted on semi-logarithmic graph. In this graph, let us understand the procedure to determine pre-consolidation pressure. First of all, we have to decide a maximum curvature point A according to our eye judgment. So I am deciding this as a point A. Next step, is to draw a horizontal line from point A, that is line AB. AB is drawn. Then I will draw a tangent AC to the curve at point A. Here AC is drawn, AB is drawn before. Then I will do, that is, bisect line AB and line AC. So horizontal line and tangent will be bisected by line AD. The bisector will be given name AD. Then this curve A will be extended to a straight line to meet the bisector AD at point P. So I will obtain the point P, and the effective pressure sigma dash at point P, that is sigma P dash, that is our pre-consolidation pressure. So this is the method to determine pre-consolidation pressure. This is empirical method. So let us keep our session up to here. We will learn consolidation more in next video. Thank you. Hello, myself Channel Popat. I welcome you all to understand soil consolidation. This is video part 2. In this video, we are going to learn Terzaghi's one-dimensional consolidation theory, as well as consolidation test setups and square root of time fitting method. Let us start. So Terzaghi's theory is among most popular theory for consolidation. Let us understand assumptions for Terzaghi's one-dimensional consolidation theory. Soil must be homogeneous. Homogeneous means it is made up of same material. Every soil particle should be of same material. Soil should be fully saturated. It should be full of water. Voids should be filled with only water. No air should be there. Darcy's law should be valid. So we have understood Darcy's law in previous videos. So it should be valid. Compression and flow should be one-dimensional. Now, one-dimensional means if you are giving compression in only one direction, flow should be only in one direction. So it is confined from all sides and only one-dimensional flow and compression should be there. Soil particles and water should be incompressible. So soil as well as water are not compressible materials. Coefficient of permeability should be constant. So K, that should be constant. Soil is laterally confined. So from lateral directions, soil is confined. It is fixed from lateral dimensions. So consolidation in vertical direction only will take place. So let us move further. Relation between void ratio and effective stress should be constant. Let us move further to theory. Terzaghi's theory of one-dimensional consolidation. We all know that the rate of settlement of soil and dissipation of excess pore water pressure is directly related. Now, to relate them and to predict time rate for consolidation, we need some concrete theory, and Terzaghi's theory is amongst popular theory of them. Due to Terzaghi's theory, we can find at any elapsed time, at any depth, we can find out consolidation and pore water pressure of the soil. Let us move further and understand Terzaghi's theory. Here in this diagram, you can see that the clay layer is in between two sand layers. Clay layer is consolidating layer here. Now we have assumed some element of size dx by dz here. In other two diagrams, you can see intensities of time as well as degree of consolidation. Here Terzaghi has empirically derived the formula for del u by dt is equal to k 1 plus E0 upon AB into gamma w into del square u by del z square. Further, if we analyze it and we assume this section as CV, CV is defined as coefficient of consolidation, which is denoted by C and in suffix V, is equal to K into 1 plus E0 upon AV into gamma W. Here we know that AV upon 1 plus E0 is MV, so we can write MV there. Now if we want to find coefficient of permeability K, we can find out K is equal to CV into MV into gamma W, and hence we can write del U by dt is equal to CV into del square U by del Z square. Furthermore, if we are talking about single drainage, there is a different case. If we are talking about double drainage, there is a different case. Let us understand single drainage and double drainage both. Now, if there is a only single layer of drainage provided either at top or either at bottom, there is a single drainage case. And if there is provided on both the sides as a drainage medium, like here we have taken, so it is a double drainage case. So small d is equal to h will be here. Now small d is what? Small d is the length through which water has to go to reach the drainage medium, that is small d. If you are using double drainage soil, you have to take d is equal to h here as we have taken. And if you are having single drainage soil, you have to take d is equal to 2h, because the length will be greater in single drainage. In double drainage it will be shorter, so we have to take half the length.